In this video, we're going to look at a challenging question that involves using a velocity time graph to work out distance. So there's three parts to the question, and they are to do with whether different cars traveling at different velocities will overtake each other. So pause the video now and try parts A, B, and C. So part A says determine the time at which A overtakes B. So we need to know the distance that A is traveling and the distance that B is traveling. And of course, the point at which A overtakes B is, and this is kind of obvious, but at the same time, it's not immediately obvious, is when they have traveled the same distance. And then, of course, we've got a velocity time graph, so the area under the graph is the distance travelled. So with A and B, you might immediately notice, actually, that A is kind of symmetrical about this point here, and actually this area here is this area here. So you might instinctively realise that at 10 seconds, A and B have travelled the same distance, and that the answer is actually 10 seconds. Now, that wouldn't be... I mean, it might be enough if you explained it well, but what you'd really need to do is calculate the area underneath the graph, and you need to show that the area of this rectangle is the same as the area of this trapezium. Now, that's really easy, and I know that you can do this. But there's a better method that we can use, and we'll use this in part B. I'll show you with part A, and then I'll show you again with part B. So what we need to really say is we need to come up with expressions for the distance travelled at any time. So for B, what is the distance travelled? Well, it's going to be the area under the graph, which is 20 meters per second, times by the time. Now, we don't know at this point what time is the answer to this question. I know we've kind of said it's 10, but if we're doing this method from the start, we don't know. What's the distance that A is travelled as a formula? Well, it's going to be the area of this trapezium, which is a half 10 plus 30 times by the time here. And then we also need the area of this rectangle here. So we need 30 times by a time. Now, we can't just say time because we're obviously starting the rectangle here, aren't we? So what we're really going to be saying is it's going to be 10 minus the time. So that way we're only counting the time from this point onwards. So now if we solve this equation, we're going to get 20t. So that's going to be equals 20t plus 300 minus 30t. So what do we do? Well, that will cancel out with that one. So now we've got 30t is 300, t is 10 seconds, which is actually what we said instinctively at the start. Let's do the same method for part B. So for car B, again, we can write down the same expression. We know that 20t is the distance travelled. What is it going to be for car C? Well, it's going to be the area of this triangle. So that's going to be half times by 0 plus 25 times by t plus this constant speed for this rectangle, which is 25, times by t minus 10 seconds. Because again, we are not interested in this first part because we've already counted for it. So we just want this first time, so this extra bit of time here. So now we can solve this equation. 20t is, that's going to be 12.5t plus 25t minus 250. So now we've got, that's going to be 37.5t. So it's going to be 250 is 12.5t, which means that t is 25 seconds. And if you want to do, you can do a quick check. You can say 20 times by 25, it's 500. You can plug 25 seconds in here, and you'll find that this is also equals 500. So this is the answer here. Now, you might have noticed here I did t minus 10, and here I did 10 minus t. This is actually the most sensible and logical way to do it. This makes a lot more sense, right? Because you're doing the time minus this first bit that we don't care about, whereas here it's less obvious. If I actually just change that round here and multiply out, we end up with this. And then if we rearrange this, you end up with exactly the same answer. So this was a little slip of my working out here, but you get the same answer. This is the most sensible way to do it. Part C, finally, will C ever overtake A? The answer is no. Why is that? Because the speed of C is always less than that of A. So no matter how far they go, C will always have travelled a smaller distance.